Hello, this is Mr. Simmons, and this is Properties of Fluids. So our objectives in this section are define and apply Archimedes' principle and contrast buoyancy and weight. We will also want to compare density and buoyancy. So our vocab in this section is weight and buoyancy. So one of our overarching questions in this section is, why do some things sink and other things float? So in your head, make a list of objects that sink and some that float. We want to generate a hypothesis about why something as heavy as a battleship will float. So here we have a battleship that's made of metal, and it's a huge object. Why does it float on water? Think about that. And it goes back to a guy named Archimedes, his principle, and the idea of buoyancy. So if we have objects that are in a fluid, that can be a liquid or a gas. That's what a fluid is, a liquid or a gas. It will experience two forces. Gravity pulling down due to the mass of the earth, and buoyancy pushing up. Buoyancy is the ability of a fluid to exert an upwards force on an object. So Archimedes' principle is basically the idea of why we have buoyancy. So Archimedes was a 3rd century BC scientist. He made a discovery about buoyancy. So the story is that apparently he jumps in a bathtub full of water. The water rises up and goes over the sides of the tub, and he yells out "Eureka!" and realizes that he displaced water, that he moved water aside, and that there was a force there. So if you've ever been in a swimming pool, and you're kind of wrestling around the swimming pool, and it's really easy to lift people up above in water. I can hold a 300-pound person in water just by my arms, and it's because water has buoyant. It is an upwards force that goes against gravity. So we can measure buoyancy by taking the weight of the fluid that is displaced. So in the last section, we learned that irregular objects, the volume of an irregular object is equal to the water displaces. So if I drop a couple pennies in a graduated cylinder, however much it goes up, that's the volume of those pennies. So if you take the weight of the fluid that is moved aside, that is displaced, that's the buoyant force, and that's the upwards force. So an object will float if the weight equals the buoyancy. So weight is the pull down, buoyancy is the push up. When they equal each other, it will float in water. Not necessarily on the top, but it will float and not sink. So infer. So why can't a battleship be made of solid steel? Think about that in your mind. Why can't it be made of solid steel? So here we're going to compare buoyancy and weight. So if two battleships are the same size, but one is solid and the other is hollow, they will displace the same amount of water and have the same buoyancy. It'll have the same amount of upwards force. The solid one's weight will be greater than the hollow one, so it sinks. So we have the upwards force of buoyancy, the downwards force of weight. Let's get a little drawing here. So right here is buoyancy. All right, and right here, and the blue one will be weight. So when those things equal each other, it will float. All right, but if the battleship is made of solid steel, it's going to have a lot more weight because the solid steel weighs more than air. So if it ends up having the same buoyancy, it displaces the same amount of water, unless water goes inside the ship, but it has a lot more weight, so it's going to sink. So it's about the combination between the upwards force of buoyancy and the downwards force of weight. All right, question 3. Explain why a steel block sinks, but a steel battleship floats. What do you think? The battleship has a much greater mass, has a much greater volume. Why does a battleship sink or float, but a small steel block sink? Well, density and buoyancy. It has to do with density and buoyancy. So density equals mass divided by volume. If an object has a greater density than the fluid that is in it, it will sink. So this directly relates to buoyancy and weight. So if it has more mass per volume than water is 1 gram per milliliter. If an object has more than that, it's going to sink. If it has less than that, it's going to float. So if an object has a lesser density than the fluid that's in, it will float. All right, Pascal's principle. Pascal lived in 1623 to 1662. He was a French scientist, discovered that pressure applied to a fluid is transmitted throughout the fluid. So this kind of goes along with a lot of different things, including toothpaste, hydraulic car lifts, and or hydraulic cars and lifts. So your toothpaste, you can squeeze on one end and it comes out the other. That pressure applied on one end of the toothpaste is it transmitted throughout the whole fluid. So this is a big physics concept because a lot of machines are based on hydraulics. And so to lift a car up, we can apply a little bit of pressure on fluid, and that pressure is transmitted throughout the whole machine. And so it has to do with pressure. So pressure equals force divided by area. So the amount of force, a push or a pull, divided by the area that's applied. So if we increase force, pressure goes up. If we increase area, pressure goes down. And that's it, guys. That is, let's go back to the beginning. That is the property of fluids, gases and liquids. We'll discuss gases next time. Thank you and have a great day.